constructed by the
This call is now being recorded.
All these models are constructed by the theory of computation. Now here I am going to explain about what before construction of the any module. Before construction of the any module. So what is the required? Okay, when will construct a module? That means, for example, if you want to do any project, okay, we need to specify the objective. What is my objective? Based on this objective only, we are going to construct a some module. That's why for defining a such kind of objective, we need to we need to know the on which format we have to give the objective. That means that is simply it is called as a language. That's why in some universities that the syllabus name is called, that is a title is formal languages and automated theory. Formal language means what? Okay, if you understand the languages, then we are going to interact with this module that is called the system. So that is called as automatic models. For construction of automatic model is the theory name is called as the automated theory. That's why in some universities the subject title is called as formal language and automated theory, or theory of computation, or only automated theory. Okay, all these headings are same as this only, but the content is same. Now here before if you want to specify the what kind of model is required, we need to understand the language. We have to specify how to specify. Suppose if you don't have the any language, okay, if you don't want if you didn't let any language, then how to interact the system? Not possible to interact with the system. But if you have the idea about the language, then only by using of instructions we can interact with the system. That's why before designing the some models, we need to learn the language. Okay, that's why. So what is my concept is here, and first we'll start from the central concepts of the automated theory. Central concepts of the automated theory are basics of the formal languages. So what are the basics of formal languages? Any language. First, we will start from the symbols. First, we'll start from the symbol. Symbol means what? Anything, any entity, any character is called as the symbol. Okay, that means symbol does not have any specific meaning. That means comma is a symbol, full stop is a symbol, so hash is a symbol, @ is a symbol. That means just what are the characters are available there, then all it is called as symbols only. But now from this symbol, from set of symbols, we are deriving the one concept that is called as alphabet. The alphabet is called as what? The alphabet is that is called basic building blocks of this any language. That is called as alphabet is called as basic building block for the any language. Alphabet. Okay, if you know the alphabet, then only we can construct some language. That's why here from symbols. From symbol can be anything, but alphabet there is called something only. So what are the alphabets as per our English language? That is called as the A to Z characters are called as the alphabets. And for example, if we take the binary language, what are the characters are there? 0, 0 and 1. Next one is if you take the decimal language. So what are the character? What are the alphabets are there? 0 to 9. That's why here what is the property for alphabet? The alphabet is a finite and non-empty set of input symbols. Okay, number finite and non-empty. Finite and non-empty set of input symbols. Okay, the alphabet is what is definition for alphabet? That is called as finite and non-empty set of input symbols. Inputs, or otherwise it is also called as the input alphabets. Finite and non-empty set of input symbols. Next, again, so the alphabets are represented by the second point is the alphabets are represented by the sigma. The alphabets are represented by the sigma. Suppose if you take the binary language, so what are the alphabets? 0, 1. 0 and 1. And sigma, if you take the English language, that alphabets A, B, C until some Z. Okay, that is called as any alphabet that can be finite. Okay, then only it is considered the alphabet. If any, for example, if any language is it contains the infinite number of alphabets are there? No. If it is infinite means what? Infinite means we cannot specify the grammar rule. We cannot specify the valid words. And whatever writing, everything is considered as the valid. But if you specify only these are valid in my compiler, only these are valid in my language. If you specify like this, then only we can identify it as whether it is the right or wrong. That's why here we are using the concept name is called as the alphabet is. What are the properties are required for alphabet? That means two properties are required. One is belongs to finite and second one is called as non-empty. Finite and non-empty set of input symbols are called as the, okay, that is the alphabet. The examples are, if you take the binary language, what are the alphabets here? Sigma equals to 0, 1. If you take the English language, sigma equals to A to Z. And if you take the ternary language, in the ternary language, what are the alphabets are there? 0, 1 and 2. 3 characters are called as the ternary language. Suppose if suppose in sigma equals to 0, 1, 2 and until so on. That means here there is no limit is there. If there is no limit means, is it considered as the alphabet? No. This is not an alphabet. The alphabet should be, what is the property? That is a finite and non-empty set of symbols. Then only considered as the alphabet. Okay. This is the alphabet. Now, here I am. What are the operations we can perform on the alphabets? Here we have the one operation we can perform on the alphabet. What is the one operation here? That is called as a power of an alphabet. Power of an alphabet. What is the power of an alphabet? Power means what? That represents the length of an alphabet. Power of an alphabet. Power of an alphabet. The alphabet is called as sigma. And power means what? Suppose we can write here sigma power 0, sigma power 1, sigma power 2, and sigma power 3 like this. The power represents what? Sigma power 0, sigma power 1, sigma power 2, sigma power 3. Sigma power 0 means what? The length of this alphabet is 0. The length of the alphabet is 1. The length of alphabet is 2. The length of alphabet is 3. Suppose here, if I give the sigma equals to A. Okay, here the alphabet is called as a sigma equal to A. Now, what about the sigma power 0? Sigma power 0 means what? The length of A is 0. The length of A is 0 means what? There is no A. There is no A means what? How to represent it in formal languages? But instead of writing the nothing, just we are using a specific some character that represents the that is called as the empty character. Okay, that is represented by the epsilon symbol. Okay, for empty strings or empty characters are represented by the one special character. What is the special character here? Epsilon. Okay, in some books, instead of this character, that is called as the, okay, this symbol also we can use for representing the empty string. Okay, and now again sigma power 1. Sigma power 1 means what? The sigma power 1 means A power 1 only. A power 1 means that is called as the A only. Next one is sigma power 2. Sigma power 2 means what? Sigma power 1 into sigma power 1. Sigma power 1 into sigma power 1 is called as sigma power 2. Sigma power 2 means what? Sigma power 1 followed by sigma power 1. That is called as A followed by A. A. Next one is sigma power 3. Sigma power 3 means what? Sigma power 2 into sigma power 1. That is called as 2A followed by 1A. Okay, likewise we are defining. Sigma power 3 is called as 4A. Sigma power 5 means that is called 5A. But here sometimes, okay, if it is a limited is there, okay, in specified sigma power 0, sigma power 1, sigma power 2, sigma power 3 like this. But if I want to accept all the strings of A's, any kind of A should be accepted. That means how to represent it? Suppose if you want to define all the A's should be accepted in our language. That means in that situation, we are using one operator. The operator name is called as the clean closure of an alphabet. K-L-E-N-E, clean closure of an alphabet. Clean closure of an alphabet. Alphabet is sigma. And clean closure means what? That is called as the sigma star. Clean closure is represented by the star operator. That is called as the sigma star. Okay, the star represents here what? That is, this is not a number, but it represents something. specify something. What is something here? 0 or more occurrences. 0 or more occurrences. 0 means what? Here instead of sigma star, we can place the sigma power 0 union, sigma power 1 union, sigma power 2 union, sigma power n. So this is called as the sigma star. Sigma star means what? Any combination of any combination, that is from the starting from 0 or more, 0, 1, 2, 3, 4, 5 until n. Now that's why if a sigma equals to a means what? Sigma star equals to what you're getting? That is called as epsilon a, 2a's, 3a's, and n number of a's. That is called as the sigma star. Okay. And next one is one more operator is there. The operator name is called as the, that is called a positive closure of an alphabet. Positive closure. Positive closure means what? Except the 0, except the sigma power 0. That means the positive closure means that is represented as the one or more occurrences of an alphabet. That is one or more occurrences of an alphabet. That is represented by the sigma power plus. Plus means here that represents one or more occurrences. One or more occurrences. Sigma power plus means that is called a positive closure. The positive closure means what? The plus represents here one or more occurrences of an alphabet is called the positive closure of an alphabet. Now, suppose here the sigma power plus equals to what? Okay, the count starts from the at least 1. Okay, that is called as sigma power 1 union sigma power 2 union sigma power 3 until sigma power n. So this is called as the sigma power plus, positive closure of an alphabet. Suppose if you take the sigma equal to a, then sigma power plus equals to what? Starts from the at least 1a, 2a's, and 3a's, and n number of a's. All the a's are represented like this. That's why finally we can write sigma star equals to what? Sigma power plus union epsilon. This is one way to represent in the closure operations. Or otherwise sigma power plus equals to what? Sigma star minus epsilon. Sigma star minus epsilon. Okay, this is the format, this is the rules for the sigma star and sigma power plus. This is called as power of an alphabet. Okay, and next one is, okay, alphabet is over. Next one is the group of alphabets, the collection of symbols which are derived from the alphabet. That is called as the string or word. So the next concept is called as the string. Because of once if you identify the symbol, from symbols we identify the alphabets. Okay, if you identify the alphabets means that what is the next level? We can write the group of alphabet as a single word. That is called as the string or word. The next one is called as string or word. Word is represented by the small w. String or word is represented by the small w. Now, what is the string here? The sequence of symbols, the collection of symbols which are derived from the alphabet sigma is called as a string or word. It is denoted by the small w. Suppose here the sigma equals to 0, 1. The sigma equals to 0, 1. That means what are the characters, what are the strings, combinations of the zeros and ones, and everything is called as a valid word or valid string. That is called as, suppose here w equals to, epsilon is a valid string for every alphabet. Epsilon is a valid string for every alphabet because of 0 length string. And next one is suppose w equal to 0, 1, 0, that is also valid. If w equals to 0, 1, 2, is it valid? No, only 0, 1 is valid, but 2 means what? Unknown character. That means in my compiler only I am using the zeros and ones only. But if you type as 2 means what? That is command R. That means the that is called as unknown character is there. That's why it is not a string. That is what is the string here? 0, 1 is called as a string. W equals to 0, 1. And next one is here. We can use empty string. Empty string means what? That is called as epsilon is called as empty string. That is okay. And now, so what are the possible operations we can perform on the string? Okay, maybe from introduction concept, maybe we'll get the one bit from this operations on strings. And again, what is the necessity to read the operations on strings here? While defining the language rules, we have to use what kind of strings are required. That means we have to, instead of writing the notations, just we are using some syntaxes only. Okay, that means these kind of strings are required in my compiler. Based on the request only, the compiler is designed. That's why here operations on strings. Operations on strings. Now, first one is length of a string. If it is not visible, all of you please note on it. Length of a string. Prefix of a string. Suffix of a string. Proper prefix or proper suffix of a string. Proper prefix or proper suffix of a string. And substring of a string. And reverse of a string. Reverse of a string. Reverse of a string. Palindrome of a string. Okay, I will explain first these operations. Afterwards, I will explain remaining operations. And first one is here. What is the side heading now? Operations on strings. Because of if you understand the strings, okay, we need to specify the what kind of strings are valid in our language. That means we have to know what is the notations of the strings, how to give the input to the system. That means if you understand all the string operations, then only we can specify the what kind of strings are required in our compiler. That's why here first one is length of a string. Length of a string means what? The number of characters are available on the string is called as the length of a string. That's why the string is called as what? W. And number of characters is represented by the mod. That's why mod W. Mod W is representing for what? Length of a string. Suppose if I consider W equals to 0, 1, 0. So what about the length of W here? 3 characters. Suppose W equals to A, B, C, D. W equals to A, B, C, D. Then what are the characters? How many characters are there? We have 4 characters are there. Suppose W equals to epsilon. If W equals to epsilon, then what about the mod W equal to 0 only? Because of W equals to epsilon means what? That is 0 and the characters are represented by the epsilon. That's why mod W is epsilon. That is called a 0. Okay, this is called as the. That means what is the need of this length of the string operation? That means whenever you representing the language constraints, we need to specify, okay, length of the string like this. Okay, length of the string is less than 10. Length of the string is greater than 10. Okay, if you want to specify like this, instead of writing the length of the string, just you have to use this format only, mod W. Mod W is for representing for what? That is called as the length of the string. W is for the string. And length means number of characters, that is represented by the mod. Okay, mod W equal to 3, mod W equal to 4, and mod W equal to 0 here. And next one is here. The main thing is sometimes we are identifying we need to accept one of the prefixes of your languages. Prefix of these strings only should be accepted by your language. Okay, suffix of the strings only, suffix of the following strings only accepted by our language. Then how to specify it? First of all, if you want to specify like this, we need to understand what is meant by prefix and what is the suffix. No? That's why. So what is the prefix? What is the prefix? The prefix is called as the leading symbols of the string is called as the prefix of a string. Suppose if I consider as W equals to ABC, W equals to ABC, then what about the prefix of a string? That is, all of you please remember it. The epsilon is a prefix and epsilon is a prefix and suffix and substring for the every string. Epsilon is prefix and suffix and substring for the every string. That is W equals to ABC. Suppose what are the prefixes are there? The prefixes are here epsilon. And next one is only A. Okay, the prefix means leading symbol from the starting. Okay, that is called as AB. Then ABC. That is called as epsilon, A, AB, and ABC are called as the prefixes of the string. Suppose if I consider as W equals to ABCD. So what are the prefixes? Epsilon, A, AB, ABC, and ABCD. Epsilon, A, AB, ABC, ABCD. Now for the same string, what are the suffixes? What are the suffixes here? The suffixes are reading from the right to left. That is called that is from the trailing characters of the string is called the trailing characters. The string is called the suffix of a string. The trailing characters means what? Okay, that is epsilon is a suffix and prefix for every string. That's why first you have to write epsilon. Then afterwards C and BC. Don't write as CP because of the same. The part is same as this, but we don't want to change any order. That's why BC, then ABC. Now here, if the string is ABCD, then what about the suffixes here? That is called as epsilon, D, CD, BCD, and ABCD. And ABCD. Okay, these are called as the suffixes of the strings. Next, what about the proper prefix or proper suffix of the string? Proper. If you get the word like the proper at anywhere, that means except the given string. Except the given string, remaining all prefixes and suffixes belongs to the proper prefix or proper suffix. That's why here the proper prefix or proper suffix means what? So what is my prefix here? Okay, except proper. If the answer is if you want to identify the proper prefix is what? Proper prefix equals to what? Except the given string. Remaining all the strings are belongs to the proper prefixes. Here suppose suffix. So except the given string, remaining all suffixes are belongs to the proper suffixes. Okay, now here also except the given string, remaining all are belongs to the proper prefixes. Except this given string, remaining all strings are belongs to the proper suffixes. Okay, this is the concept related to the proper prefix and suffix. And next one is prefix and suffix values. Okay, and now. So what is mean by, and again, all of it please note down one point here in the gate point of view. Okay, the string length is n. If the string length is n, if the string length is n, how many number of possible prefixes and second one possible suffixes and possible prefixes and suffixes. Sorry. And possible proper suffixes and proper prefixes. Okay, all of you getting or not? If the string length is n, how many number of possible prefixes? First question. Possible suffixes. Second one. Possible proper prefixes and suffixes. Proper suffixes. So what about the possible prefixes? If the string length is n, then possible suffixes and prefixes are belongs to the n plus 1. The string length is n. How many number of possible prefixes and suffixes? That is n plus 1 only. Then what about the proper suffixes and proper prefixes? The proper prefixes and proper suffixes are belongs to the n only. Because of here we are eliminating the given string. Remaining all prefixes and suffixes are related to the That is proper only. That's why here except the given string, remaining all prefixes and suffixes belongs to the, that is the proper. So the proper suffix and prefix are only the n only. The string length is n. Number of proper prefix and suffix also n only. Okay. And next one is substring of a string. Next what? That is called as the substring of a string. Substring of a string. Substring of a string. So what is my substring of a string? Suppose if W equals to ABC. So what are the substrings here? Epsilon, A, B, C. Sub part of the string is called as the substring of a string. A, B, C, A, B, B, C. Then A, B, C are substrings of strings. Epsilon, A, B, C, A, B, B, C, then A, B, C. Suppose if W equals to A, B, C, D, then how to what are the substrings of strings here? Epsilon, A, B, C, D, A, B, B, C, C, D, A, B, C, B, C, D, then A, B, C, D. Epsilon, A, B, C, D, A, B, B, C, C, D, A, B, C, B, C, D, A, B, C, D. Okay, generally we are writing the substrings of a string. But is there any formula to get the substrings of a string? Is there any procedure is there? Yes, we have the procedure is there, and we have the number is also there. How many possible substrings are there? Okay, I will explain how to get the substrings and how to write the substrings. Suppose if you want to identify the substrings of the strings, if you want to identify the substrings of the strings, we can take either prefix or suffix from the given string. Suppose from this string, I am going to write the prefix of this string. Suppose these are the prefixes. So what are the prefixes here? Epsilon, A, B, sorry, A, B, A, B, C. So these are the prefixes. Either we can take the prefix or suffix set, no problem. Suppose if I cancel the prefix set, if I take the prefix set, now if you take the input as a prefix set, we have to find out the suffix. If you take the prefix set as input, we need to calculate the suffix. That's why what is the suffix of epsilon? Epsilon only. So that is there. Next one is what is suffix of A? Epsilon and A. A is also there. Already epsilon marked, no problem. Next one is what is the suffix for AB? Epsilon. Okay, already is there. B. B is there. Next one is BA. Sorry, AB. AB also there. Next, afterwards, what is the suffix for the ABC? What is the suffix for ABC? Epsilon already is there. Next one is C is there. BC is there. Next one is ABC. That's why here for finding the prefix, for finding the substrings of a string, just we can take either prefix set or suffix set. But if you take the prefix set as input, we need to calculate the suffixes from this prefix set. Okay, the result is called as the substring of a strings. Substrings of a strings. So that is called as the substrings. How to find out the substring? But here that is not a problem for finding the substrings of a string. But here, what is my question is, if the string length is n, if the string length is n, how many number of the string length is n? How many number of substrings are possible? That is my question. How many number of possible how many number of possible substrings are there? That means if you identify here substrings, so what is the problem? Okay, here if I consider the string length is 4, that is called as string length is n, means n equal to what? 4. Now if I take the on string length 1, how many strings are there? 4 strings are there. On string length 2, how many are there? 3. On string length 3, how many are there? 2. On string length 4, how many are there? 1. That means because of here n equal to 4, 4 plus 3 plus 2 plus 1 format is there. Suppose if the string length is 5, means what? Okay, the string starts from the what? 5 plus 4 plus 3 plus 2 plus 1. This series is repeated. What is the series name? Sum of n natural numbers. That's why sum of n natural numbers means what? N into n plus 1 by 2. N into n plus 1 by 2 plus, along with this epsilon, we have one more symbol common, that is called as the epsilon. Epsilon means that's why represented as the 1. So if the string length is n, how many number of possible substrings are there? That is n into n plus 1 by 2 plus 1. N into n plus 1 by 2 plus 1. Suppose we can count here, that is called as the string length is n, that is equal to 3. 3 means 3 into 3 plus 1. That is called as 3 into 4. That is called 12. 12 by 2 is 6. So 6 plus 1 is 7. Now count here 1, 2, 3, 4, 5, 6, 7. Okay, the first condition is satisfied. If n equal to 4, 4 means what? That is called as how many strings are there here? Substrings 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Is it 11 is possible to get from by using this format or not? Now that is called as n equal to 4. 4 into 4 plus 1, that is called as the 20. Okay, 4 5 is 20. 20 by 10. 20 by 2 is 10. 10 plus 1 is 11. That's why this condition also satisfied. That's simply it is considered the how to calculate the substrings of a string, that is called as the based upon the prefix set and suffix set. And the main thing is here, the main thing is that is called as the if the string length is n, how many number of prefixes and how many number of prefixes and suffixes are n plus 1. How many number of possible proper prefixes and suffixes are, that is n plus n only. Next one, how many number of substrings are there, that is called as the n into n plus 1 by 2 plus 1. Okay, these are the 3 bits from this introduction concept. Now if you understand the substring concept, the next operation name is called as the reverse of a string. Next one is reverse of a string. The reverse of a string. The string is W. Reverse means what? How to represent it? W power R. The reverse of a string is represented by W power R. Okay, if W equals to ABC, then reverse of W is called as CBA. The reverse means if you write a string in reverse order, that is called as the reverse of a string. Now, what about palindrome of a string? The given string is said to be a palindrome if and only if W equals to W power R. W equals to W power R. Okay, the given string and the reverse of string both are same. It is considered the palindrome of a string. Suppose here W equals to ABA and W power R is also called as ABA. Suppose W, what is the example of palindrome strings? Suppose madam. Okay, series. Okay, madam, series. All these are the examples for the palindromes of a string. Okay, and next. And these are all operations we can perform on the on single strings. But if you have more than one strings, what are the possible operations? Concatenation of the strings and union of two strings. Okay, these are the some operations on based upon the more than one string. Union of whose strings? Union of strings. Union of strings. The union of strings are called as the union operation name is called union, or operator, or plus. Union or plus. All three characters are representing for the union operation. That is, suppose W1 is ABC, W2 equals to DEF, then W1 plus W2 or W1 plus or W2. Union W2 equals to what? That is ABC, comma DEF, or otherwise DEF, comma ABC. You can write any direction. Okay. But now, what about concatenation? Concatenation is that is represented by dot operator. Concatenation is represented by the dot operator. It is called as W1 dot W2. W1 dot W2 means ABC followed by DEA. That is called as W1 dot W2 means ABC followed by DEA. Without having any spaces, we need to concatenate W1 and W2. Or W2 and W1 means what? DEF followed by ABC. So these are some operations performed on the strings. Once if you understand all the possible operations, we can specify the language. That's why the next module belongs to the language. Next one is language, next level. Next one is language. So what is meant by language? The language is represented by the capital L. The language is represented by the capital L. The language contains a collection of strings which are derived from the or which are chosen from the alphabet sigma. The language is a collection of strings which are derived from an alphabet sigma is called as language. Otherwise, language can be defined as subset or equal to the sigma star. The language can be defined as subset or equal to the sigma star. So what is meant by sigma star here? Sigma star, already I explained about the sigma star. The all combination of alphabets are called as the sigma star. Suppose if I consider as sigma equals to 0, 1 binary. And next one is what about the sigma star here? Any combination of zeros and ones will be considered as a sigma star. Epsilon 0, 1, 1, 0, 0, 1, 1, 0, 1, or any combination of zeros and ones will be considered the sigma star. Now, so what is the language here? The language that is equivalent to the sigma star, or otherwise we can take any subset of the strings. Any sum of the strings will be considered as our language. Any sum of the strings means what? Suppose in my language, the length of the string should be less than or equal to the 3 only, or less than or equal to the 2 only. Less than or equal to 2 means what? Okay, in my language, the language L equals to the number of the strings. What kind of strings are valued here? The length of the string. less than or equal to the 2. Such kind of strings only valid as per my language. That's why here in that language, what are the strings are there? Epsilon, 0 and 1, 1 0, 0 1, 0 0, 1 1. Okay, these are called as these 7 strings are called as the valid as per this language. But here, that's why based on this concept, the language can be classified as a two types mainly. That is called as the finite and infinite language. Infinite and finite. Infinite language and finite language. So what is my infinite language? If any language contains the infinite number of strings are there, that is called as the infinite language. And next one is finite language means what? If any language contains the finite number of strings are there, that is called as a finite language. So these are some examples related to the languages, and what are the operations performed on the strings? All operations can performed on the language also. Union, concatenation, difference, set difference, and everything. Okay. Any doubt till now?
No, sir.
Okay, now next one. Now I am going to designing models. And before going to the designing a model, if you understand the model, what is the structure of the model, then you will start the designing of NFA and DFA. First, finite automata. Finite automata means what? That is called as everything is finite here. Automata means that is called a self-acting device. Finite automata is a self-acting device or self-acting model. Then what are the types are there here? We have the based on application classified as a two types finite automata. That is called as the finite automata without output, and second one is called as finite automata with output. Finite automata without output, and second one is called as finite automata with output. The finite automata without output, that is called as the application name is called as language acceptor or language recognizer. The language acceptor or language recognizer. And next one is here the finite automata with output, that is called as the transducer. Transducer means what? That is called as the converting from the one form to another form. This is electrical word, but here also converting from the input to the output. That's why this application name is also called as the transducer. This is also called as the transducer. Okay, first one is called as finite automata without output. So that means here we are not going to generate any output. Simply that is generates the particular string is valid or invalid. That is accepted or unaccepted. Okay, that's why for this application, what are the missions are there? We have two kinds of missions are there for implementing this concept. That is called as DFA and NFA. This is called as DFA, deterministic finite automata, and NFA is non-deterministic finite automata. And here in the finite automata with output, that means here we don't want to verify the given string is valid or invalid. Only we are generating the output for the given input string. Okay, for generating such kind of outputs, what is the machine is available here? We have two machines are there, Mealy machine and More machine. That is called as Mealy machine and More machine. Now again in NFA and DFA, here in DFA we can't use any epsilon transitions, but if it comes to the NFA, we can use the NFA with epsilon transitions also. NFA with epsilon transition also. By default, NFA means there is no epsilon transitions, but sometimes if they ask about the construct a NF with epsilon transition means we have to use the epsilon symbols instead of the input symbols. And next one is Mealy and More emissions. Okay, if it is completed, that means the first task is over. and again minimization of DFA, equivalence of find automatas, how to converting from one model to another model. Okay, all these topics I will explain one by one. Okay, now I am going to explain about the. So what is meant by find automata? What is meant by DFA? What is meant by NFA? Okay. Okay, now 1 minute. 1 minute. One minute, please. Okay. Now first find automata. If you take any find automata, either NFA or DFA, what is the notation? Everything can be represented by the 5-tuple notation. What are the 5-tuple notation? The finite automata M, mission M, can be described or can be defined by using 5-tuple notation. So what are the 5-tuple notation? Q, sigma, Q naught, delta, and F. Q, sigma, Q naught, delta, and F. So what is meant by Q? The machine means M. And what is meant by Q? What is my sigma? What is my Q naught? What is my delta? And what is my F? That is, where Q is a finite and non-empty set of states. Where Q is a finite and non-empty set of states. Next, where sigma is a finite and non-empty set of input alphabets or inputs. Sigma is a finite and non-empty set of input alphabets or inputs. Next one is where Q is a finite and non-empty set. Where Q naught is a initial state. How many initial states will be there in every mission? Exactly only one initial state. That means always processing starts from the particular state only. That's why Q naught is the initial state and Q naught belongs to what? Capital Q. That means that is also one of the state from the capital Q. And next one is transition function or mapping function. That is represented by the delta. Transition function or mapping function of the automata. So what is the transition function? The transition function is called as the how to moving from the one place to another place. That is called as how to moving from the one state to the another state. Okay, how can you moving from one state to another state? That means if you are in the some specific state, from the state, if you read some input symbol, then only we can go to the next state. That's why here you should be in the any one of the state from the capital Q. That is called a capital Q. And next one is from the any one of the state from capital Q. If you type any input symbol, that is called a sigma. Okay, Q and sigma based on these two characters. That means the combination of both. That's why here you're using into Q into sigma gives. And then it goes to the what? Here we are not generating any output. Just we are moving to the next state only. Next state is also belongs to one of the state from the capital Q. That's why Q into sigma gives capital Q. And the next one is here F means what? Final state, set of final states. Why it is called a set of final states? We can use more than one state as a final state. That is depends upon our application. That's why F or it is also called a capital A. Capital A for what? Accepting state. Okay, that is called as the capital A means that is accepting state. Now the set of final state F subset are equal to the capital Q. F subset are equal to the capital Q. That is called as set of final states or subset are equal to the capital Q. Now, suppose just I am giving the one real-time example for this find automata. If you take the lift, lift is one of the best example for the find automata. Okay, how can you compare to the find automata and lift? That means if you take the lift as example for find automata, the number of states Q. Okay, the lift is a machine. The number of states. What are the states here? Okay, that is called as the lift will be used in the some apartments. That's why here that is called or any offices. That means if the more than one floor is there, then only we can use. That's why here that is called the here it is considered states. Na? There you can consider the number of floors. Floor. Next one is input symbols. What are the input symbols here? That means in the lift we have to how to interact with the machine. That means by using of the button 1, button 2, button 3. That is called as the input symbols are called as the sigma. Next one is Q naught. Q naught means what? The initial state. Initial state means what? If you type from the ground floor or anything, that is called as always starts from the ground floor. If you put the condition like this, the initial state is the ground floor. Next one is the main. Why I am explaining this example is for understanding the transition function. Transition function means what? How to moving from the one state to another state. Suppose in the lift, how to moving from the one floor to another floor. Suppose you should be in the one floor. From there, if you press the button 1, then go to the first floor. If you press the button 3, that means go to the third floor. In this way, we are moving from the one floor to another floor. Here also, you can take any one of the state from capital Q. From here, if you type the some input symbol, then it will go to the next state. That is also belongs to the one of the state from capital Q. Next one is final state. The required floor is there. That is called as the final state. Okay. Now, but how to represent the find automata? The find automata can be represented in the find automata can be represented in two ways. One is called as the transition table and transition diagram. The find automata can be represented in two ways. One is called as transition table and transition diagram. So what is the transition table and transition diagram? That means the transition table or transition diagram. Suppose I am going to explain the first one is transition diagram. Transition diagram or transition graph. Transition diagram or transition graph. Now the graph means set of vertices and set of edges are there. The same way here also, what are the vertices and what are the edges? Okay, vertices are related for the states. Next one is the edges, that is called as the input symbols. That's why suppose the states, how to represent the states by using the circle. Inside the circle, we can write the name, state name. And if any state start, if prefixed with the arrow mark, that is called as the initial state. And final states are represented by the double circle. Final states are represented by the double circle. Suppose okay, these are the some, for example, this is the some structure automated diagram. Here, what are the states here? How many states are there? 3 states are there. Suppose if I want to explain the M format, that is called a Q. Q means what? Set of states. What are the set of states here? Q0, Q1, and Q2. 3 states are there. Sigma. Sigma means on edges. What are the symbols are there on edges? 0, 1. 0, 1. Next one is initial state is Q naught only. Q naught is Q naught only. Next one is transition function. Transition function means what? Delta of Q naught comma 0 equals to Q naught. Q naught comma 0 is Q naught. Q naught comma 1 is Q1. Q1 comma 0 is Q2. Delta of Q1 comma 1 is Q1. Q2 comma 0 is Q1. Delta of Q2 comma 1 equals to Q2 only. Delta of Q2 comma 0 is Q1 and Q2 comma 1 is Q2. And what about final state here? The final state is F equal to double circuit, that is called as the Q2. This is called as the final state. And next, again. So the same diagram we can represent it in the form of the table also. Table means what? Set of rows and columns. The rows for the states and columns for the input symbols. That's why, suppose if I consider as the input symbols are zeros and ones, initial state as is represented as the arrow mark, Q1 and Q2. That is represented by this some star operator. Now Q0 and 0 is Q0. Q0 and 1 is Q1. Q1 and 0 is Q2. Q1 and 1 is Q1 only. Q2 and 0 is Q1. Q2 and 1 is Q2 only. Okay. Now this is called as the diagram and the table format. Now here, what is the how to already I told the before starting the find automata. What are the applications of find atom? Mainly classified as the language acceptor or language recognizer, and second one is called as the transducer. That's why language acceptor, language recognizer means what? That is the language. Okay, that means the particular string. The language contains what? Set of input strings only. Okay, the set of input strings are accepted or not. That means how to identify the particular string is accepted or not. That is verified by the automata. Then how to decide the automata is accepted or not? By the end of the string. By the end of the string. End of the string. If it is possible to go to the final state or not. By the end of the string, if it is possible to go to the final state, that is considered as the accepted by this automata. Suppose if I consider as 0, 1, 0, 1 is there. 1, 0, 1. From Q always starts from the Q naught only. 1, 0, again 1. 1, 0, 1. By end of the 1, 0, 1, where it is? That is at the Q2 only. Q2 is belongs to final state. That's why 1, 0, 1 string is accepted. Suppose if I give the 0, 0, 1. 0, 0, 1. 0 means 0 only. Again 0 means 0 only. 1 means what? Where it is what? At the that is halt at the Q1 only. Okay, that means 001 is not accepted by this find automata because of by the end of the string the current state is not belongs to final state. That's why based on these two points we can identify whether the given strings are valid or invalid. So this is called as the acceptance of the find automata. Now here comes to the find automata is okay, but find automata classified as the that is called as the two types because of as per the language acceptor, language recognizer, NFA and DFA. NFA and DFA. First, we'll discuss about the DFA. DFA also same as it is like I already explained about the NFA. Okay, Q, sigma, Q naught, delta, and A. But what is the DFA rules? From every state, how many states are there? From every state, on every input symbol, there is a path. There should be a path. But how many number of times? Every excuse me. 1 minute, Nana. Here there is no power. It's raining here.
Okay.
Please 1 minute, Nana.
Okay.
Is it visible or blurred?
Yes, sir.
కనిపిస్తుందమ్మా పర్వాలేదా కంటిన్యూ చేయనా లేకపోతే ఆపనా స్టాప్ చేయనా పవర్ వచ్చే వరకు ఏనా
లైట్ పడుతుంది సార్ అక్కడ.
అండ్ లైట్ అంటే విండోస్ తీసాను అది పవర్ లేదు పవర్ పోయింది వర్షం పడుతుంది బయట
రైట్ సైడ్ లో రాయండి సార్, ఎక్కువ పార్ట్ లెఫ్ట్ సైడ్ వద్దు.
ఇక్కడమ్మా
ఎస్
ఓకే
అక్కడే.
Okay. The DFA M is same as this. Q equals M equals to Q sigma Q naught delta and F. So what is the transition function? Majorly, what is the difference from NFA and DFA is majorly that is different on the that is a transition function only. The transition function for DFA is Q into sigma gives Q only. But NFA is Q into sigma gives 2 power Q. I will explain why that the 2 power Q. Now here the main thing is DFA rules are from every state on every input symbol there should be a path. But on every input symbol that is okay 0. Is it 0 contains more than one path from the same state? No. Exactly only one path on every input symbol from every state. Then only that is considered the DFA. That means DFA means deterministic. Directly I have the solution without having the confusion. That means exactly only one path should be there. But if you have more than one path is there on same input symbol for reaching the same destination, definitely you will get the confusion. If you get the such kind of confusion, that is not a deterministic, that it is called a non-deterministic. That's why in NFA, non-deterministic, on same input symbol, we can use no path, or otherwise only one path, or more than one path also we can use on the same state or from the on same input symbol. That's why if there is no path, sometimes we can't decide it. And so, and there is, and we have a single path, no problem. But if it is on same symbol, we can have the multiple paths are there. If you have the multiple paths, definitely will get the confusion. That means which path we are going to select. Is it first path or second path or third path or like this? That's why if you get such kind of confusion, such kind of systems are called as the non-deterministic systems. That is called as the non-deterministic finite automata. Okay, now once if you understand the DFA, because of DFA we have to follow the rules. What kind of rules? First you need to accept the language. Afterwards for sets once if it is the things are accepted, and again we have to frame the DFA rules. What are the DFA rules? From every state on every input symbol we have to define the path, and without change the meaning of the given language constraints. So that is called as the DFA concept. Now I am going to construct a DFA. Suppose DFA for the construct a DFA for the construct a DFA for the to accept all strings of zeros and ones. To accept all strings of zeros and ones. All strings of zeros and ones. all strings of zero. If any designing, first we need to write the what is the accepted by this language. That means what are the valid strings as per this language? Any combination of zeros and ones. Means what the language L equals to what? That is epsilon is valid, 0 is valid, 1 is valid, 0 1 is valid, 1 0 is valid. Any combination of zeros and ones are valid. Any combination of zeros and ones are valid. That's why any combination of zeros and ones means what? Epsilon 0 1 1 0 0 1 1 0 1 001, all strings are valid. Then that's why first how to start the construction of the DFA. Okay, please remember this point. Okay, if you want to accept any string based on the string length, how many states are required? If the string length is n, how many states are required? N plus 1 states are required minimum. N plus 1 states are required to construct a finite automata for the any language. That is called as here. First we'll start from the minimum string. What is the minimum string as per this language? Epsilon. Epsilon is what? String length is 0. That's why if the string length is 0 means what? How many states are required? 0 plus 1 states are required. So minimum is 1 state is required. Now this is called as Q naught. Now is it accepted? No. Okay, when will it becomes acceptance? Okay, if it is belongs to the final state. That's why for accepting the initial state, okay, the epsilon is for accepting the epsilon, if you mark the Q naught as a final state, initial state as a final state, so it is accepted by the finite automata. That is called as epsilon is belongs to the accepted. Okay, if epsilon is accepted means what? That is called as the if Q naught is the initial state as well as the final state. Okay, now 0 should be accepted. And again, is it belongs to the DFA? No, because of here we have the two input symbols are there. We have to define the two input symbols from the Q naught. Then only it is considered the DFA. That's why if I give the Q naught and 0, Q naught and 0 means what? If I give the self loop here 0, no problem. 0 is accepted. 2 zeros accepted. 3 zeros accepted. Any number of zeros are accepted. Next one is same as this 1 also. 1 is accepted. 2 ones are accepted. 3 ones, 4 ones. That means 0 followed by 1 is accepted. 1 0 is accepted. That's why any combination of zeros and ones are accepted. That's why here the Q naught and self loop, Q naught self loop on 0 1 is called as DFA for the given language. Okay. Now again, now I am going to construct the remaining problems. Construct a DFA. Construct a DFA for the even number of zeros. Construct a DFA for the even number of zeros. Over and sigma equal to 0 only. Even number of zeros. Even number of zeros means what? The language L equals to epsilon, 2 zeros, 4 zeros, 6 zeros, and so on. Epsilon, 2 zeros, 4 zeros, 6 zeros. Okay. And now first
సార్ వీడియో కనిపించట్లేదు సార్.
అది ఇక్కడ పవర్ లేదు నాన్న. నేను మొబైల్ డేటా చెప్తాను.
అంటే మొత్తం బ్లర్గా ఉంది సార్.
వర్షం పడుతుంది ఇక్కడ.
ఇప్పటి వరకు బాగానే వచ్చింది సార్. ఇప్పుడే బ్లర్గా ఉంది.
ఇప్పుడమ్మా
ఎస్ సార్, ఇప్పుడు బాగానే.
ఒక హాఫ్ అన్ అవర్ వల్ల కంటిన్యూ చేస్తాను. Epsilon 2 zeros, 4 zeros, 6 zeros, and something. And now for accepting epsilon, what is the state? Initial state marked as the final state. So Q naught, final state. Next one is here. What is input symbols? Only 0 is input symbol. Compulsory you have to give the 0 as input symbol. Okay, Q naught on 0. Shall I give the final
Q1, sir.
Q1? Na?
Yes, sir.
Yes, compulsory. Because of if we give self loop here, single zero is accepted, but single zero is not available in our language. That's why compulsory have to give to the Q1. It is 0. Now again Q naught is on output input 0 is okay. But what about the Q1? Q1 should be Q1 on 0 is. But this is a single 0, and again to get a second 0 is compulsory has to go to the final state. That's why okay, for odd number of zeros, exit from the final state. For even number of zeros, enter into the final state. This loop will be repeated. Afterwards, any combination of zeros are accepted. Even number of zeros are accepted. And again here, we have one property is there. Suppose here, what is the property? The regular languages are closed under the complement. The regular languages are closed under the complement. Regular language means what? The language which are accepted by the finite automata. These are called as the regular languages. Are called as the regular languages. The regular languages are closed under what? The regular languages are closed under the complement operation. Now here, this belongs to the even number of zeros. Suppose if I want to construct a finite automata for the DFA for the odd number of zeros, without changing the number of states, without changing any transitions, without changing any initial states, or without changing any input symbol, just only we have to change the final state concept. Only have to change the final state. How to change final state? Okay, here now this belongs to the even. Now if I want to get the odd number, just swap the final states or non-finals, non-finals or final. Then you get the answer for the reverse. That is called as odd number of zeros. Odd number of zeros. Next. Construct A. Construct A. DFA for the construct A DFA for the following language L equals to 0 power n, 1 power m, m comma n greater than 0. Construct A DFA for the following language L equals to 0 power n n and 1 power m for mango. Okay, m where m comma n greater than 0. That means what are the strings are valid as per this language? That is called as the language L contains 0 1 is valid. 0 1 is valid. 0 0 1 is valid. 0 1 1 is valid. 0 0 1 1 is valid. That means zeros followed by ones, but the number of zeros, n number of zeros followed by the m number of ones. Okay. Now, first, what is minimum string here? 0 1. Minimum string is 0 1. That's why how many states are required? 3 states. Because of here, n string length is 2. Q naught, Q1, and Q2. 0 and 1. 0 and 1. Now, as per the DFA rules, okay, Q naught on 0 is there. And what about Q naught on 1? If any string starts with starting with 1 means what? Invalid. Invalid means compulsory it has to go to the trap state or dead state. That is called as Q3 means if any string starts with the 1 means that is invalid. If any string starts with 1 means afterwards any number of zeros and ones that is also invalid. 0, 1 self loop here only. This is not a final state. Next afterwards. Okay, Q1 on 0. Okay, After 0, single 0, any number of zeros also valid now before ones? Yes, that's why here you can give the self clue. 001, 0001, any combination of zeros and followed by 1. Next, Q2. Here Q2 on 0. Q2 on 0 means what? Once if you enter into the number of ones, is it possible to get again 0? No. As per our language, that is wrong. Ending with ones only. That's why again you have to assign to the dead state. Then afterwards, 1 followed by, we can use any combination of ones, no problem. That's the self. So this is called as the diagram for the 0 power n, 1 power n. Am doubt in the వీటిలో?
సార్ మళ్ళీ ఒకసారి క్లారిటీ చెప్పరా?
Okay, Nana, here the language L equals to 0 power n and 1 power m. Okay, n for Nepal, m for that is called as mango. And now what are the strings are there? That is m comma n can be greater than 0. That's why the minimum string is 0 and 1. 0 length is 1 and 1 length is 1. So string is 0, 1. Next one is 001 or 011, 0011, 0001, 0011. Okay, that means starting with zeros and ending with ones. So these are called as the valid strings as per the given language. Now, first, if any language, first we need to start from the minimum string. What is the minimum string here? 01. What is the length of this minimum string? That is called as n only. That's why here that is the 2, n equal to 2. The how many states are required? 3 states are required for accepting the 01 string. That is Q0 on 0, Q1, and Q1 on 1 is called as Q2. That means 01 is accepted initially. Afterwards, now I am going to add the remaining edges. What are the edges here? Q0 on 0 path is there. But what about Q0 on 1? Q0 on 1 we have to add it. Suppose here this is the initial state. Initial state means the process starts from here only. Maybe if any string starts with 1, is it valid? Not valid. Because of always string starts from at least a single 0. But if any string starts with 1 means what? Invalid. That's why we are assigning to the new state. The new state here is called as the trap state or dead state. Because of if any string starts with 1 means afterwards any number of zeros and ones, always it has to go to the trap state. That trap state means what? There is an exit from here. That's why zeros and ones loop will be here only. Afterwards, okay, Q0 having 0 and 1 path are there. Next one is Q1. 1 path is there. But what about 0 path? 0 means what? Before this one, we can use any number of zeros. That's why here we can give the self loop. So no problem. 0, any number of zeros followed by 1. So valid as per our language. Okay, Q1, 0 and 1 is there. Next one is Q2. The Q2, 1 means what? After a single 1, any number of ones are valid. Na? That's why Q2 on 1 is valid. Q2 on 1 is valid. Q2 on 1 is valid. That's why it has assigned to the final state. Now again, what about Q2 comma 0? Q2 comma 0 is called as, that should be exit from the final state. Because of after ones, first zeros, followed by ones, followed by ones only. There is no possible to get the again zeros. That's why if you write the again 0, that has to assign to the dead state or trap state. So this is okay, Nana? Ekkada doubt unda nana? ఏ పాయింట్ దగ్గర?
లేదు సార్.
Okay. Next. Construct a DFA to accept all strings of zeros and ones construct a DFA to accept all strings of zeros and ones. First one is even number of zeros and even number of ones. First bit is, that means all strings of zeros and ones. Okay, but what kind of strings should be accepted? Even number of zeros and even number of ones. First follow. Even number of zeros and even number of ones. Second one is even number of zeros and odd number of ones. Even number of zeros and odd number of ones. And third one is odd number of zeros and even number of ones. Third one is odd number of zeros and even number of ones. Fourth one is odd zeros and odd ones. Fourth one is odd zeros and odd ones. Okay, what is the problem now? To construct a DFA, we accept all strings of zeros and ones. First problem is even number of zeros and even number of ones. And second one is even number of zeros and odd number of ones. And third one is odd zeros and even ones. Fourth one is odd zeros and odd ones. Odd zeros and odd ones. Okay. కనిపిస్తున్న ఒక స్టిక్కర్ అన్న బోర్డ్ ఇది మొబైల్ కదిలిన రీడ్
ఎస్ సార్ బాగానే ఉంది.
Now first one is even zeros and even ones. LEE. I represent it as LEE. Even zeros and even ones. So first tell me what are the valid things as per the language. Even zeros and even ones means what? Maybe epsilon also valid. Because of zero number of zeros and zero number of ones. Only 0 also valid. Double 0, 1 also valid. 0 1 also valid. Or 1 0 also valid. Okay, these all are the valid notations. And now first we are going to identify the epsilon. Here epsilon is the initial string. That's why initial state as marked as the final state. Then epsilon should be accepted. Afterwards, what? Even zeros and even ones. Even zeros means what? Compulsory. This is for the odd zero. Again, even zeros means compulsory it has to enter to the final state. Okay, zeros. Even zeros are accepted. Then afterwards, even ones. 1. Again 1. Okay, 0 0 0 0. Even number of zeros and even number of ones are accepted. Now what about remaining edges? Remaining edges means what? What are the missing edges here? Q1 on 1 is not there. Q1 on 0 1 is there, but Q1 on 1 we need to add. And next same way Q2 on 0. Q2 on 0. Where should I add? Chepnana? Q1 on 1 and Q2 on 0. Are two edges ఇంకా మన pending one. These two edges are pending.
సార్ Q2 నుంచి Q1 కి 0.
Okay, good. If I Q2 on 0 is Q1. Next.
సార్ మళ్ళీ Q1 దగ్గర నుంచి Q2 కి 1.
Okay, if you add like this. Here, what is our mission or what is our constraint is, what are the strings are valid as per the given language? All strings should be accepted if your construction is correct. And next one is, what are the strings are invalid as per your language? Such kind of all strings should be rejected by this automata if the construction is correct. That's why. Suppose what is our language now? 1 0 0 1 0 0. Is it accepted or not? 1 0 0.
సార్ వీడియో బ్లర్ గా ఉంది సార్, కనిపించట్లా.
బ్లర్ అయిందన్నది ఫుల్ వర్షం పడుతున్నా, అది అందుకే నేను ఇప్పుడు ఇప్పుడమ్మా
ఓకే సార్.
ఓకే. Now here 1 0 0 1 0 0 is accepted na,
ఎస్
but
సార్.
1 0 0 should not be accepted na.
ఎస్ సార్.
That's why this path is wrong. That means this 0 path is wrong. Suppose now from this path 0 1 1 is also accepted na, 0 1 1 is also accepted na, 0 1 1.
No sir, because 0011 or 1010.
00 11 is it accepted? 0 0 1 1 is accepted, okay. But what I am telling, 0 1 1 is accepted or not from this diagram? 0 1 1.
సార్ అప్పుడు ఒక జీరోనే వస్తుంది కదా సార్, కానీ ఇక్కడ మనల్ని అడిగింది ఈవెన్ నెంబర్ ఆఫ్ జీరోస్ కదా.
That's right అన్న, అది చెప్తున్నాను ఏంటంటే 0 11 is accepted or not here?
నో సార్.
ఇక్కడ యాక్సెప్ట్ అవుతుంది అన్న 0 11. అలా
సార్
యాక్సెప్ట్ అవ్వకూడదు.
వాయిస్ వినిపించట్లేదు సార్.
Here in this diagram 0 11 is accepted or not?
నో సార్.
Accept అవుతుందన్న, Q0 and 0 is Q1, Q1 and 1 is Q2, Q2 and 1 is called as Q0.
హలో,
Okay.
అర్థం కాలేదు సార్.
వినిపిస్తున్నానా?
ఇప్పుడు వినిపిస్తుంది సార్.
అదే మేబీ ఇక్కడ వర్షం వస్తున్నా అంటే ఫస్ట్ నెట్వర్క్ ఫ్లక్చుయేషన్ వల్ల కూడా అది కొంచెం వినపడదు. హియర్ Q0 and 0 Q1 కదమ్మా.
ఎస్ సార్.
నెక్స్ట్ అగైన్ Q1 and 1 is Q2 కదా.
ఎస్ సార్.
And next one is Q2 and 1 is Q0 కదా.
ఎస్ సార్.
So finally we can reach to the final state. So 0 11 is accepted, but it should not be accepted. That's why invalid strings also accepted by our automata. That's why this is a invalid construction. Okay.
ఎస్ సార్.
So this is a invalid format. Q1 and 1 also compulsory we have to take some new state. Okay, next class continue చేస్తాం.
ఓకే సార్.
We can take some new state that is called as Q3. That is 1 here and here also 1 0 and here 0. Okay, all the strings are there, all the states are available. Here I taken some new state. Okay, Anna? Now we can verify any combination of even number of zeros and even number of ones are accepted. Okay.
సార్ ఒకసారి ఆ Q0 Q1 ఎలా తీసుకుంటాం ఒకసారి చెప్పండి సార్.
Q0 Q1 is first one is even number of zeros followed మనకి even number of zeros.
సార్ అక్కడ మనకి ఫస్ట్ మినిమం దగ్గర యాంబసెంట్ ఉంది కాబట్టి నెక్స్ట్ స్టెప్ ఏంటి సార్?
Q0 is initial state అయింది కదమ్మా.
ఎస్ సార్.
సో మనకి ఏంటంటే 0 పాత్ యాడ్ చేయాలి. హౌ టు యాడ్ 0 పాత్? నేను ఇక్కడ కానీ సెల్ఫ్ లుక్ ఏమవుతుంది, సింగిల్ 0 కూడా యాక్సెప్ట్ అవుతుంది. సో నేను సింగిల్ 0 వచ్చినప్పుడు బయటకు పంపించాలి, ఎగ్జిట్ ఫ్రమ్ ద ఫైనల్ స్టేట్. సో కాబట్టి ఏం చేస్తున్నాం, Q0 and 0 is we have to take some new state Q1. ఓకేనా? హలో,
వాయిస్ బ్రేక్ అవుతుంది సార్, వినిపించట్లేదు.
ఇక్కడ వర్షం పడుతున్నా, నేను రేపు నేను నెక్స్ట్ వీక్ క్లాస్ లో కంటిన్యూ చేయండి లేకపోతే.
ఓకే సార్.
అది బెటర్ కదా నాన్న. మళ్ళీ
ఎస్. ఓకే సార్.
ఓకేనా? మళ్ళీ ఎప్పుడు తీసుకుందాం క్లాసు? హలో
సార్ నాకు తెలియదు, మీ ఇష్టం సార్, మీరు ఎప్పుడు పెట్టినా వస్తాం సార్.
ఓకేనా, ఒకసారి నేను మేడం గారికి ఇన్ఫార్మ్ చేసి చెప్తాను.
ఓకే సార్.
ఓకే థ్యాంక్ యూ.
థ్యాంక్స్.